Elisabetta Carnevale. Elisabetta Carnevale is an architect and an earth design and construction consultant. She holds a postgraduate degree in earthing architecture from Catalonia, IAAC Grenoble. After working for UNESCO on earthen-built heritage in Ecuador and researching earth potential uses for design at AMACO Research Center in France, since 2018, she is a faculty member of the postgraduate in 3D printing architecture here in IAAC. She is currently combining academic and research work with the professional activity of Arquitectura de Terra, an architecture and earth design consultancy practice here founded in 2018 here in Barcelona that explores contemporary possibilities for earth and other sustainable materials both in Catalonia and in the Middle East. So after this very synthetic presentation, and I am glad to welcome Elisabetta Carnevale and her lecture, Architecture Made of Earth. So thank you, Elisabetta, for being here with us today. You may share your presentation and begin whenever you want.
Thank you, Fabio. So I'm going to share my presentation with you. Yeah. Okay.
Now we are with the PDF. We are not seeing the full screen. Maybe you can stop and share again.
Okay.
Now, perfect.
Yes.
Yeah. Yeah.
Great. Okay. Good evening, everybody. I am really honored to be here and to give a lecture about how you can build with earth, which is my passion and my job. I'm so honored that actually this morning I was reviewing the TED Talk advice to give the greatest talk, and like the first one was dream big, share an idea that could actually change the world. And I thought, oh, that's easy. That's what I'm going to do. That's what I'm doing. I'm sharing an idea that I really believe could change the world. So I'm going to go through the reason why I think building with earth is a great idea. And I hope I will leave you some of the interest I have for this material after this talk. Well, I'm an architect, as I said, and I'm Italian. I come from Turin in the north of Italy. It's a region in Piedmont where actually farms are traditionally built with earth. But growing up there, I just couldn't realize that it was actually an astonishingly good idea to build with earth. And that's because in architecture school, the image we had of what a sustainable building should look like was more something like this, right? Something very modern with active system and photovoltaics modules and a lot of steel and glass, basically. So when I got out of school, I started working in architectural practice and trying to apply some bioclimatic criteria and some sustainable idea to my design. But at this very same time, I also started going to construction sites, seeing what was actually there before and during the fact that our designs were built. And I got quite shocked, I must say, because I realized that beside this beautiful picture of a piece of architecture that we can see on the internet or on monographies, there was a lot that wasn't said and that wasn't told, right? The fact that there was some piece of landscape that would be modified for a very long span of time by a building, and the fact that this relationship maybe was not that soft. Maybe sometimes it was a bit violent. And the idea also that at the end of the building life, there was a lot of material that would never have been used again, that was impossible to recycle. And also the fact that I started realizing how our architecture was somehow a facade architecture. In many cases, I realized that there was the main material we were using, and then there was some facade material that was just concealing what we didn't want to see about our own design and our own constructions. And all of these things added up, and I started not feeling that well anymore about what I was doing. So I decided to take a sabbatical year, and I started wandering around South America, basically. And at some point I was in the Andes, in the Chilean Andes, and there it was. I bumped into earthen architecture. That was a traditional way to build, and it made a lot of sense there because it's a place where it is virtually impossible to bring some material in order to build. So everything must just use what is right under your feet or just around you. And at the same time, it made a lot of sense, not only from a material point of view, but also when we look at the integration of this piece of architecture in its landscape, because it was made out of the very earth that was there. And you knew that one day it would be very easy to reintegrate it into the natural resource cycle. And at the same time, this concealing idea was not there anymore, right? Every material was right there in its place with its function, but it was visible. So I was deeply fascinated, and I still thought it was something just folkloristic and that I would never see again when I went down from the mountains and into the city. But at the very contrary, I realized that there in Chile and in Argentina as well, there was a young generation of architects that was actually carrying on this material, because this material, earth, was never really out of fashion in construction. People were still using it, they never stopped. And therefore architects were trying to experiment with it and try to use it in contemporary design and together with other materials, trying to literally reverse the use of the mud brick, like in this example. So that was my aha moment. I thought, okay, this can be done actually, and it makes a lot of sense. It is an answer to contemporary architectural needs. I want to learn how to do it, and I want to bring this with me, and I want to diffuse this when I come back. So, and there it was. I left the Andes for the Alps, and I moved to Crater. Crater is the largest world research center about Earth. And it has a postgraduate cycle that lasted 2 years, where you basically are a group of 20 people from all over the world in love with Earth, and you just keep learning and experimenting about this material. I learned a lot, as you can imagine, and still I learned a lot about the material, about Earth and heritage, but I wasn't really sure about how to use this material as an architect for contemporary architecture. How could I start the very same day to build with this material now and here? So together with another architect that had the same questions after this postgraduate, Annelise Antoine, we set up a research project. We raised funds, and we decided that we would make a call and ask anyone in France that had built with Earth during the past 30 years. So we started from 1975 onward, and we started collecting material about, and we made a map about all of this building that were made with Earth. We had almost 200 buildings, and at some point we say, we want really to get to know these people and ask them questions. So we started for a road trip that lasted almost 2 months. We picked not the 100, but just the 30 most interesting of this, most interesting ones of these buildings. And we made hours and hours of film interviews with their architects, their contractors, and the clients of each of them, the promoter. So here is where we really felt we got a grip about what does it mean and how does it work today to build with this material, its pros and cons, its difficulties, its obstacles, but also the leverages, the reason why all of these very different people built with earth. And after this, I really felt ready. So I was, at the time, I moved to Barcelona and I started my own practice. And as soon as possible, I started building with earth. So this is a yoga center that was completed in 2018. As you can see, it's made of earth and wood. It's into an existing building, and it was the first building here in Barcelona metropolitan area using prefabricated rammed earth blocks, which are quite an innovative technique. And then from here, I realized it was also important that I could help other designers and other architects to build with earth, not just to wait for the perfect client, the perfect project in order to make a nice design, but really to help diffusing this material. And this is when I got in touch with other people that I met during my my path that are also earth experts, and we work together as a team of consultants now on projects. For instance, like this is a project, a very recent one. It's a primary school in Nanterre, in the outskirts of Paris, and it really shows how earth made it into one of the most difficult sectors, which are public buildings, especially in France, which are buildings that have an enormous amount of regulation and of any type. And still, when you see that this kind of building has earth, we really see that there is a path. And actually, we already see that other buildings are following this one. So architects, architectural practice, together with some consultants, some expertise just about the material, can really bring this material up to what would otherwise be just another building with conventional materials. So long story short, I had to pick some things that I wanted to share with you. It was hard, but I managed to select 8 things that I want to tell you about my beloved material earth. The first one, you could guess, is that earth is sustainable. It is the main reason, right, why we go toward this material, but I think it is really important to understand why and how we can say it is sustainable. First of all, earth is a local material. Local means really local. In very few cases, we are able to use the very same ground that we excavate in order to build, but in most cases, and I would say in any case where earth is used, earth comes from a very short range from a very short radius. This means no transport. This also means that earth is an available material in an era where we are badly running out of sand, for instance, because of concrete construction. Having a material that is local and largely available is an asset, I think, for resilient architecture of tomorrow. Local also mean that there are some pioneer projects like this one, BC Materials, from it's in a Belgian project from a Belgian cooperative. They are actually setting up an on-site building material production, so they are able to come to the site and to excavate and to produce the materials, like for instance the bricks or the plastering, just with the earth and just on site. This way they are minimizing really down to zero what is the transport, and I think it's an extremely interesting approach to construction, right? Nowadays our materials travel a lot of kilometers. Being local is not only a material aspect, but it also means earth and architecture has a very strong connection with a place. And using earth, sometimes it is also a way to show and to advertise this relationship. This is a very recent building. It's a museum in China that is placed into a city which is famous for its earth, which is famous for its porcelain production. So having this museum built with earth really materializes the relationship that this place has with the earth and material. And this is the very earth the porcelain is made of. And of course, it can also materialize a relation a brand has with the land. Of course, you know, I'm pretty sure you know this building, the Ricola Herb building by Herzog and de Meuron, having this candy factory with where candies are made with herbs that come from the land, and the herbs are stored in an enormous earthen building. Of course, it is a very strong statement for this brand. It has a very strong connection to the meaning of what they do. Not only earth is local, but it has a very low embedded energy. This means a very little energy is needed in order to use earth that we can extract just from the ground. This is very important because when we look toward what is sustainable architecture, or the architecture of the future, we concentrate a lot on what is the energy efficiency of the building. And this is important because the operation of our buildings, as you can see, is responsible for 28% of the overall world's greenhouse gases emissions. It's a lot. So we better really have more efficient buildings. But we still can see that another 11% is still on our side. It's still on the shoulders of the building sector, and that's due to materials. And most of it is due to the materials we know very well: concrete, iron, and steel. 9% of the world greenhouse gases emissions. So while everybody is concentrating about how can we reduce this 28%, I think it is also important, and we work on this 11%, which is still an enormous amount of pollution and of use of energy. Especially because we don't need that much energy to have building materials. Earth, you can see it here, has a ridiculous embodied energy when we compare it not only to concrete but even to fired bricks. Okay, I didn't put steel and glass in this diagram because they wouldn't fit the slide by far. So, but you can imagine, okay, that there is a very huge disproportion in what is the energy we need in order to produce a steel beam or a reinforced concrete slab, and the one that we need in order to extract earth and maybe to compact it. Because yes, in most cases, we are able to use earth just as it is without stabilizing it. This building is a very nice example of it. This building was the image of this talk. I really want to state that this is not a project of mine. I really wish I could have this in my portfolio. It's a building by Design and Architecture and NAMA, to an architectural practice and some earthing consultant practice. And it's a public building. It's the European Conservatory of Soil Samples, made of earth, of course. It was made using local earth, reformulated and combined with another earth partially, but with absolutely no stabilization. So it is pure earth, it is completely recyclable and natural. Third, once we have built with earth, our building can be pretty much energy efficient. I'm not saying earth is the perfect material, but it's a material that has very important properties that are really useful once we have to design our indoor comfort, our thermal and our moist levels. First of all, it's a material that has a very important thermal mass, a thermal capacity and a thermal mass. It is a material that is very dense, and this is why, as you can see, it is really able to shift what is the peak of heat, especially in summer. This is a quality that is especially important in summer, while we use a lot of energy for air conditioning. Well, Earth is really able to shift the penetration of the heat inside in our indoor space. So it can be used in indoor climate strategies, passive ones. And of course, it is very useful when we have to store something that we want to keep at a very uniform level of temperature and of moist. This is one of the reasons why we have so many earthen buildings that have to do with wine production and cider production, as you can see here. But also museums, of course, because what I have in a museum normally requires a very stable temperature and moist level. But of course, we also want that for our homes, right? And this is the reason why we have a lot of projects that are developed combining heating system and earth, right? We have a heating system generating heat, and this earthen element that, as you can see, is also integrated into an interior design, which is responsible for keeping there this heat as long as possible and really distributing it very slowly during the day. This is an important energy efficient strategy. I choose the black background for this slide to add a touch of mystery, because even if we know so many things about Earth and about its thermal behavior, we still don't know all of it. You can see here the difference between, you see the dotted line, this is what our computer simulation would expect that our rammed earth wall temperature would be. And you can see the other line, these are all of the tests. So actually this rammed earth wall behaves much better than we expected. Why is that? Why is this wall able really to regulate temperature, to have such a stable temperature with no big fluctuation, which is very good for comfort? Well, this man down here is the one who's been researching about this property for the last decades. And his name is Joseph Colsani. He's based in southern France. He's an architect and researcher and constructor. And he's actually developing together with universities this the system called Heliothère, which is enhancing a very important property of Earth. Earth is one of the very few natural phase-changing materials. What is a phase-changing materials? Laboratories are trying to synthesize very advanced and synthetic phase-changing materials. These are materials that actually have some elements, some particles inside of them, which is able to evaporate and to condensate. And this releases and absorbs energy, and it goes just the way we would like it went. It means when actually the temperature is going up, we have this evaporation, and this evaporation is actually absorbing energy. So if it's getting hotter, my wall helps my indoor climate to stay fresher. And on the other way down, when the temperature goes down, these particles are condensing inside of the building elements, and therefore they are actually releasing energy just when I need it. Well, as you can imagine, this fluid that we have inside of Earth is water. There are some particles of water that are always present into an earthen wall, even when it's completely dry. They are always there. They are stuck in between the clay particles of Earth. And this is why their thermal behavior is so interesting. And the fourth point about sustainability and Earth is that it is 100% recyclable. And this means it can really operate in a circular economy approach, a topic that is really, really hot nowadays. How can we make our economy circular? How are we able to minimize waste and reuse what we've been using already. This is very important, especially for us as a designer, because 40% of the generated waste in the European Union is due to building sector. It's enormous. Okay, we are recycling, we are separating our garbage every day. We're doing really well, but then we are dumping an enormous quantity of non-recyclable material because of our buildings. So how can we revert that? How can we change this paradigm? Once again, I'm showing you another part of the project by BC Materials, this pioneer cooperative in Belgium. Not only they are producing materials on site, but they also rethinking how once this material has been used, when they have to dismantle an earthen building, they are see how they can actually reuse this earth and either giving it back to earth, which is what they propose this just here with the barrier. So the earth is able to go back into a natural circle. Either another really interesting way to exploit earth recyclability is to use all of the excavated earth. Cities and in general, countries tend to excavate enormous volumes of earth. And this earth is incredibly considered as a waste material, as a useless material that is going to a dump. It even has a cost, actually, to be dismantled, instead of using what it could be a perfectly suitable building material. 1 year ago, finally, when the project was set up, in order to try to avoid this crazy dynamic. The name of the project is Cycloterre, Earth and Cycle. It's an European funded project and it takes place in the metropolitan area of Paris. The metropolitan area of Paris is extending its underground network. This means kilometers and kilometers of tunnel are going to be excavated between now and 2030. Which means 400 million tons of earth are going to be digged out, excavated. So these projects think about what to do with this earth. How can we use it as a building material? So the project put together a series of stakeholder of partners, which are, of course, researchers and architects, but also real estate developers that are actually being taught how to use this material later on in their projects. And from all of this excavated earth, 3 lines of products are being nowadays produced. They've been set up and now they are starting the production, which are earthen blocks, as you can see, earthen panels, which are like thin elements that are able to be used in lightweight construction, and earthen plastering, earthen renders, what we put up on the wall when we want to have it finished. The 3 of them are made out of excavated earth, and this is a way to give a use and on one side to all of this material, and on the other side, it's a way to start building with a natural and recyclable material. Second point, earth is connected to our architectural heritage. We've been using earth for a very long time now. And even if for us here in Europe, it seems like it's a new material because we lost track about how we used to use earth. The estimation is that nowadays nearly 1/3 of the world's population still lives in an earthen building. You can see it is really a material used in most most populated region of the world. So pretty much everywhere we go, we will have a local earthen construction tradition. It is very much true here in Catalonia, for instance, where actually even the city of Barcelona had a lot of inner walls made of round earth, and they are discovered from time to time when houses are renovated. There was in particular one region of Catalonia, which is the region of Lleida, Pla d'Urgell, in the inner part of Catalonia. This is where really round earth culture lasted until the 70s of this century. So it is really alive, and this is also why it's a region where many things are happened. Contractors are getting specialized in round earth. We have Fettetera, which is an important material producer. And so it's a region that is particularly lively when it comes to round earth. Here you can see some Catalan round earth workers. As I said, until the 70s, that we have tracks of buildings that were built with this material. And it is very curious that the round earth technique is actually the same technique that is used also in Asia. You can see this picture is from Korea or in Africa. It is really the very same technique developed in different corners of the world. And sometimes having this heritage can really be a trigger for building with earth. It's the case for this enormous project that I'm really glad I'm helping with. It's in Saudi Arabia next to a heritage site, which is built with Adobe. And the government decided that they would actually build an enormous extension of this around this heritage sites that would all be built with earth. It is going to be a very big project, but also a very big challenge for Earth to answer contemporary needs, because this area will have, of course, museum, but also residential spaces, and they will have to keep with contemporary building standards. All of this with Adobe, which is probably the most forgotten earthen technique in contemporary architecture. You see everywhere round earth that is on trend. Adobe bricks need a lot of surface in order to dry under the sun, and this is why they are really not matching our industrialized building culture. But it is a technique that has a lot of potential, and I really hope this project will help showing and demonstrating this. Heritage is not always a good point for building with earth. Sometimes it can be the trigger for it, but sometimes on the other way, there is a bad stereotype about earth. This is due to the fact that earth was a popular, building material for popular social classes. So it was used in vernacular architecture, in farms, in rural areas, and sometimes, therefore, it got associated to poverty and even sometimes to bad quality buildings. So this is why sometimes it is a material that has a stigma that got rejected. And nowadays it really has to reprogram its image. To give you an example, this is one of the projects that I saw in my road trip, is in northern France. And that's a region where the traditional earthen technique is cob. Cob is a very nice technique using earth at the wet state when it's wet and just molding it as if it was a sculpture. It's a beautiful technique. It's a technique that makes most sense in this region where it rains a lot. But it was a social housing project in the 90s, and people absolutely rejected the idea of going to live in cob houses because they associated that with poverty, and they had the feeling that the government was trying to sell them some houses that were bad quality and not of the right standards. So what the architect did is to do some rammed earth instead of cob houses, and just by changing the technique and using the same material but with a different technique, the image of it was different. It was of an exotic or a different and new technique, and therefore it was socially accepted. And I'm talking about 1991 in France. So you can imagine how strong the stigma still is in developing countries, for instance. 4, earth is participatory. And this means earth is a material that allows for non-industrialized collective building processes. This is something that was never out of fashion in most developing countries, people helping each other in order to build their houses instead of having some professionals doing. Nowadays here in Europe, at least, we are discovering participatory building processes, training together with participatory buildings where you go and help and learn. And it works very well because earth is a material that is quite accessible to people with to people who are not construction professionals. I saw it very clearly in a very nice experience I had where I was working at Amaco, Les Grands Ateliers. This is quite a magic place in France where actually architecture school students can go and they can build one-to-one scale prototypes. They can really build small buildings and pavilions. And when I was there, actually the architecture students from the Grenoble Architecture School, they were designing and building themselves this prototype, which was called Terra Nostra. And it was actually designed as a unit that could be disassembled and reassembled in order to be prefabricated and assembled on site and stack one to each other in order to form housing buildings. And it was actually this project was connected to an actual real estate development in the city of Grenoble. So it was really a test for something that had to be developed for real. And as you see, it was combining wooden structure and earthen filling in different forms, in rammed earth forms and also in earth and fiber blocks, as you can see here. And I really saw with my eyes students doing all of this, students just like you. They did the round earth, they did the plaster, they did the earth and fiber blocks, and at the end they assembled the building, they disassembled it, they transported it to Lyon city, and they built it again in order to stand there as a visitable prototype. So yeah, students of your age built this together with a little help of cranes and transportation system. And this was the result. It was definitely inspiring, and the construction of the real buildings is starting this year. And this year, the same school, the same Grenoble Architecture School, did it again. Actually, the students designed and built, of course, with some professional help, a community center in Four, in a village nearby. And this is the result. This community center already won 2 important awards, the American Architecture Prize of this year and the Architizer Prize. And it really stands as a, as a very interesting experience to have a whole building designed and built by students with 100% natural and recyclable material is definitely an asset. 5, Earth is going strong. it is going strong in many senses, right? We have the idea that Earth is, sometimes the stereotype that Earth is a weak material, that it can't be load-bearing, for instance. And here you can see this challenge that always BC materials took on of reformulating the best rammed earth possible and building a 15 meters high self-load-bearing wall. So you can see here how on one side the technique is growing and it is advancing and is actually enabling us to control more the structural performance of Earth. But it's not just about structure. We are also we are also advancing a lot in what is the prefabrication. You can see here Martin Rauch. I'm pretty sure you've heard of him. He's the principal pioneer craftsman doing rammed earth, and in particular prefabricated rammed earth. As you can see here, this huge workshop allow him to have 100-meter long span of wall, and just being able to cut it and to transport it like huge blocks, like huge bricks. This is really the top-notch level of prefabrication, but prefabrication is also getting current in ordinary rammed earth construction, as you can see in this other project, which is a healthcare center in a French village. Even cob, which is another very interesting technique, even cob is going forward and toward prefabrication. You can see this facade, for instance, was entirely built with prefabricated cob already back in 2002. We have new design solution in order to insulate earth, insulate rammed earth, as you can see here, which is not always advisable, but still sometimes it can be the most adequate solution, and therefore we are technically able to solve this problem. There is this experimentation about poured earth, which means using earth pretty much as concrete and stabilize it with cement. So it is not really a sustainable solution yet, but the experimentation is going on, and maybe sometime soon we will be able to actually use earth in a liquid state inside of a framework as we do now for concrete, without adding stabilizer like cement. And then, of course, there is 3D printing. Okay, here you see the second prototype house by Wasp in Italy. It is being finished right this time. But I'm pretty sure you saw also the very interesting project you have at IAAC, right? The postgraduate 3D printing architecture. I think they are still exposed from Friday presentation. They are really trying to find innovative solution for 3D printing with earth. And it is a technique that has a lot of potential, because it can really combine parametric architecture and all of the advantages of having just one system integrating many aspects and many functions with a sustainable material like earth. So on one side, earth is going strong, and on the other side, we also have to know where to stop and know where to actually embrace vulnerability. This is a very nice quote by Anna Heringer, an architect that works a lot with earth. And I think it marks a very important point, right? We are there to improve what is the performance of Earth, of course, but we also want Earth to be what it is, to be Earth, right? We have a lot of projects nowadays that are being published, and they use earth, but they use earth just as if it was concrete. And in order to do that, they add cement inside of the earth. And this is a pity, because at the moment where we add cement, our earth wall starts having the same cement content than a concrete block. And it loses all of its sustainable potential, right? The low embodied energy is gone. The recyclability is also gone. We really lose a bit the path of why do we want to use earth. This is, of course, my own personal opinion, but I think we can really take it as a challenge on one side and not just as a limitation, and to see where this vulnerability of earth, I'm talking about the fact that earth cannot be directly under the rain. You can say here it is, but normally if you have natural earth and you leave it just uncovered on its top face, the rain is going to penetrate inside of this wall and it's going to bring it back to mud. It is recyclable for real. This means it can happen during the building life if we don't protect it, adequately. This doesn't mean we can't use earth. Of course, if we have rain on the side face, for instance, this is not a problem. We just need to cover the top and the bottom of it. But this is very important. And maybe we just can use earth according to what it is and to this characteristic it has, and see where it leads us. Maybe it will lead us to an architecture that doesn't look like concrete architecture. Maybe it can, for instance, here, right, the fact that earth has to be protected beneath a roof, but at the same time that earth can be a completely flexible material, it led to a much more interesting architecture than if we just had a straight concrete wall, I think. This kind of spaces are really peculiar to a material that is completely flexible like earth. 7, earth is sensual and it's getting naked. Okay, I want to stress the fact that earth is a material that really want to be touched. I'm pretty sure if you passed in the IAAC hall and you saw this 3D printed earthen models, I'm sure you had the temptation of going to touch them. It's a material that really, since it's natural and it's so rough, and it has all of this texture and all of these grains, it's a material that really calls for contact. To me, it was a big challenge to design a yoga center. It was also very nice to have to think how a person experiences architecture, not just through the sights, but also through the touch and to the feel, and every type of people also, and how would they feel when they would be surrounded on every side by earth. Would it feel like being underground? Would it feel warm? To me, it was really interesting to answer to this question, and also to have the feedback of all of the users of this space. And of course, I think earth is also a way to bring some touch and some texture and some nature to places that normally are really artificial and cold, like, for instance, a cemetery or a hospital, a healthcare center. This place tend to be all clean and smooth and white, and maybe adding the roughness and the texture and the naturality of earth can help us create different spaces for these functions. And as you can see, another of my concern as a designer, which was about the fact that materials are being concealed, I think earth gives also some interesting hints in this sense, right? We are tending more and more toward an architecture of materials, where materials are the real luxury. Materials and showing them is what really makes the quality of the space. And in this game, Earth, of course, can really play its role. And eighth and last point, Earth is trending. This is, I think, is a very strong point when we think of this material, because maybe we will really have the chance to have Earth as the current building materials in the following, in the next years. Let me be honest, Earth is not a new material. It can be innovative to use it, but we've been using it for quite long nowadays. We're talking about, yeah, what, 10,000 years? And still, I'm talking about the fact that we've been here before, not just here using Earth, but in this very, very situation when we are now. It was not so long ago. It was in 1973 when we had the first oil crisis, and for the first time we realized that natural resources were not endless, and that maybe our model of society and of consumption of them was not sustainable for real. And back then we already had the same shock and the same reaction to this shock, which was that institutions started to be interested in Earth as a material that was local, with low embedded energy, etc. And that's where, at least I'm talking about France, which is the case I know the best. That's when earthen buildings and public earthen buildings started being developed. You can see here the Domaine de la Terre. This was a pilot project, but actually the government released an architectural competition for a whole neighborhood, actually a small village, where all the best architects, the most renowned architects, they actually gave their answer, and they built this neighborhood out of the earth as a material, together with the latest architectural design concepts of the 80s. And it went incredibly well. This neighborhood is still visited nowadays. People are still living there, and they are quite happy about it. As you can see, the earthen parts are in great state. We can't say the same about the concrete part, but yeah, this experiment, this pilot project was a success. So why did it stop there? Why weren't there a follow-up of other communities, and why didn't this become a current building material? Well, that's because the crisis stopped. The oil prices went back to normality, and we just went back to our bad old habits and still building with the same not so sustainable materials. Well, nowadays we are facing a second chance maybe to change our paradigm, our model, since we are seeing really the climate change around us and the finishness of resources. And as you can see, public and in general earthen buildings are also, the number is very slowly raising in France and all over Europe. So maybe this is the chance. Big architecture stars are starting using earth. We have the Pritzker prizes, Guangzhou, Renzo Piano, they are using earth in their projects. So this will, of course, change a bit the status of this material. And public buildings are really a very important trigger, because when a public building is realized, it means all of the regulation has to give an answer about how to use this material. And in general, it really changes the image of one material as the material that really has a reason to be used. We are facing a crisis, as you know, and following this crisis, which was triggered by COVID, there are enormous there is a very big rescue plan in Europe that is going to bring an enormous amount of money, and it has sustainability as its first pillar, its first goal. will this mean we will have more occasion, more chances to use natural materials in our projects? I hope so, but I think as designers, we really have to be ready. We really have to be prepared and to give answer to this this global emergency we are facing. So I really hope I gave you some reason to be interested in this material and maybe even to love it as I do. And I'm really glad to share all of this with you, and I'm longing to answer your question if you have any. So this is it. Thank you for your attention.
Thank you, Elisabetta. It has been really wonderful. I think you have been very clear. Also, that you have been very graphic about some of the key points you wanted to show and share with everyone. No? Maybe I will ask you to stop sharing the screen so we can maybe give students the opportunity to ask some questions. I'm sure, I mean, they have was in increased order. Yeah, we have had some comments in chat, but maybe first we can have people that want to open their microphones and ask you something, and maybe let me share this. Okay, great. So, who would like to make the first question of the presentation?
I can go, Fabio.
Oh, Fatima. Okay, great.
Hello, Elisabetta. I am Fatima from Iran, now studying and living in Valdaura. It is really nice to meet you. From the first day of arrival, we start to explore Valdaura soil and clay with a group in Valdaura, and we baked here soil that is super nice. And actually, we start to set up ceramic workshops here in Valdaura for next term. And we went to OTF final presentation last Friday with a group of students from Valdaura, and I listened to your comments, and I have so many questions from you. So it would be nice if you have time to talk in a proper time about our actually proposal, and we have written one business plan on our ceramic workshops. So it would be nice if we could hear your comments on our ideas.
Yeah, thank you, Fatma. Yeah, I got this information by Mika. He wrote me about that. I still have to answer, but I definitely will. And I'm really happy that you're starting using Valdaura soil. We actually came to Valdaura with the OTF to start collecting soil sample and starting studying what can be done with this earth. And of course, many things can be done.
We can't wait. Okay, thank you.
Thank you.
Okay, great. Thank you, Fatima.
Okay.
Can
I go?
Yeah, sure. I don't know who is talking. Oh, okay, Marile, go, yeah.
Hello, Elisabetta. Thank you for your presentation. My question is, in your experience as consultant and architect, what are some of the biggest challenges you have faced when integrating this material into the practice? And with which other material would you say Earth has the best dialogue in terms of joinery and tectonic?
Nice question. What is the most difficult? I would say regulation, because you can always give a reason for a higher price than conventional material, or you can justify, or you can find a solution for a technical issue. But yeah, regulation sometimes is an obstacle, because sometimes it requires a lot of testing, and it can be a bit of a complication. But of course, as you saw, all of the project that I showed, they went through all of these path, and they manage to realize the project. So it's not a blocking element, but I would say it's an obstacle. And which material fits best with Earth? Well, I think all of natural materials fit well, because in general, they are softer. It is complicated to join Earth with a material that is very hard because of the deformation it might have due to moist changing, etc. And of course, because it makes a lot of sense, right? You want to build with Earth. You don't want to put, I don't know, asbestos together with it, right? You try to have an overall concept of what your material choices are. There is, by the way, there is a very interesting architectural competition which is closing tomorrow, which is called Terra Fibra Award. And it is combining earthen and natural fiber projects. So when we talk about natural fibers, it's of course wood, but also all of the other types of fibers. So I think it is very interesting to say the two categories together in just one prize, and because there are many projects that are using both categories of materials.
Okay, thank you, Elisabetta. Thank you, Marilia. I now know Matilde wants to ask you a question.
Sure.
Hi, Elisabetta. Thanks so much for the lecture. How are you doing? I thought it was really interesting, the comments you were making on this idea of the cultural image and how earthen architecture is often associated, as you were saying, to, let's say, a lower social class. And I was wondering if, also thinking about your collaboration with the postgraduate in 3D printing architecture, what kind of role do you think maybe new technologies or different ways of using earth within the architectural realm could play in sort of changing this image, or potentially sort of upgrading, I don't know if that's the right word, but upgrading this image?
I think it can definitely have a very important role. And you can see it, well, the example I was presenting was just about changing from one technique to another one. And it was already effective. And I think bringing in something like parametric architecture and fabrication, it will completely give a different approach to earthen materials.
Okay. Great. I would like to jump to a couple of questions we have in chat. The first one is, how high buildings can be built with earth? What's the biggest or highest building made from earth so far?
Okay. Well, the highest building we know about are in Yemen. I'm talking about the city of Shiban, which was made of adobe, quite a peculiar adobe walls. Of course, the basement of these walls is very thick, but they went up to 11 stories. So this is the highest load-bearing earthen structure we know about. In most recent time, we know about some 6-story building in Germany in the 40s, and yeah, this is more. It is more easy to achieve this kind of result out of this particular culture they developed back in the time in Yemen.
Sure. Another, let's say, specific question is, how does earth materials support ventilation and security in case of natural disasters?
Ventilation and security.
Yeah, I suppose there are like 2 points in that question. One is about ventilation, the relation with earth. I suppose the thickness of walls and how are I able to make holes and windows in these kinds of structures. And the other one should be related with security and natural disaster. I suppose earthquakes, maybe fires or something like that.
Okay. Well, about ventilation is a design issue, so there is no problem in using earth. Nowadays, there are even projects that has incredibly large openings because they use some very thin steel element integrated at the bottom of the earthen part in order to follow the contemporary architecture design needs. So there is no problem at all to have openings. About natural disasters, there is a whole branch of earth design, which is the seismic resistant earth design. Many solutions were developed, so I would say there's definitely an interesting material for seismic regions. And Chile is a region when this research is going on a lot, since it's a very high seismic risk region, and it is also mostly built with earth. So there is a lot of research going on with that.
Okay, great. Now, Veronica is asking, in terms of affordable housing in the context of Europe, is earthen architectural viable?
Well, this is an interesting question. It's a quite complex one. We are talking about comparing the costs of building with earth with building with other materials, right? Here we have two factors. In our pricing model, what is not current, it is normally more expensive, right? You can see this in biological food, for instance. You need to put less additives to biological agriculture, but it ends up costing more because you will have a fewer production, and it is not so current. You don't have this economy scale, so the price is higher. Well, a bit of the same happens in earthen architecture, since it's something that is not that mainstream. Its cost is not lowered by the very massive production on one side, and on the other side it depends a lot on the technique. But for instance, rammed earth, even if it's prefabricated, it still means that there is somebody here that is working in order to compact this earth. Even if it's done with mechanical engines, it is still a person's time, right? Labor. And nowadays in construction, we have a ridiculous labor cost, because most things come from very far, where actually labor cost is really low. But earthen architecture, or at least most techniques, right, rammed earth or Adobe, implies that the labor cost of the time of the person that is been working in this is embedded in our earthen material, and this makes its value and also its cost higher than standard construction material. So these are the reasons why, if you just look at the final cost of a building, building with earth is not going to be cheaper unless you build it yourself, which is a possibility, as I showed you in this student houses, but also in self-built houses, which are quite a large share of earthen architecture nowadays. So besides that, many social housing projects were done with earth, because being a sustainable material, the different cost is counterbalanced by the interests, right, of the public sector to use natural materials. So it can be suitable for this kind of projects.
Yeah, I think, as you said at the beginning, it's a very complex question. It has very different phases around the situation of problem.
Pricing, yes.
Maybe, Moni, could you read your question, please? Even your English is much better than mine.
Oh, I was, thank you so much, Elisabetta. That was a wonderful and super inspiring lecture. I do believe you kind of just touched on the answer a little bit. I was curious about the differences between the labor commitments and requirements for earthen building versus a standard construction, because I've often heard that it's more expensive in the labor, and that's why it's such a deterrent. And I just thought if you could comment on that at all, but I think you already just sort of did as well, so maybe just elaborate if you like.
Yeah, about labor, definitely. And about regulation, yeah, it is slowly getting appearing in the national regulation and international regulation, but we are still way beyond. It is still considered as an experimental material in many countries, which is quite crazy if you think that we are using it for 10,000 years, and we still need to prove it as if we were building with some completely new experimental material. The only technique that is pretty much under regulation is the compressed earth blocks. So the bricks that are made by compression and not the adobe. Those are have norms here in Spain, for instance, and in many other countries. In general, one big problem with earth is that it is a material that is different everywhere in the world. Of course, wherever you go and dig, you will have a different earth. So being a non-homogeneous and non-standard material makes it even a bit more difficult to have regulations. But the main obstacle is really the will and the dynamic of having this material regulated.
Perfect. Thank you, Elisabetta. And we have several questions. Maybe now, Kevin, can you go please with your question?
Hello, thank you for your lecture. I really appreciate how you began your talk and your journey in earth construction with these interviews of workers. I wonder, what did you learn from them and how has it guided your practice?
Thank you. Well, it was an enormous learning, right? Because I really got the behind the scene version of all of these projects, right? When you see it in a magazine, you don't really understand how hard it was or what maybe went wrong or what they would have done differently. To me, it was very important both to learn really tactics and how you could actually, for instance, how can you overcome all of the regulation obstacles. They actually developed some strategies in order to do that, or even on a technical level, right? Sometimes they just had an idea that was wrong and they had to catch up with it, because they are really, most of these projects were quite innovative. They were pioneers. They didn't have really a lot of feedback of other projects. So this is why they really learned by their mistakes sometimes. And that, I think, it was the most interesting part. The other part that I think was very valuable about all of these interviews was their why, right? Even if sometimes it was super complicated and it took a lot of time and money, everyone was really proud and happy about having built something with earth, and that was also really meaningful to me. And I started realizing that really this material was, I don't know, moving something and touching something inside people that was special. That was the idea of really doing something in a way that felt better for them.
Thank you.
I will read another of the questions in chat. It says, I would like to ask if the earth has to be clean to be used in a building. In north of France and in Belgium, there are a lot of polluted earth because of the mining of coal in the past that have to be cleaned when we do a building on a polluted place. Is the polluted earth worth enough to build a house and avoid health issues?
Wow, this is a very interesting question. I think it definitely depends on the type of pollution that we are talking about, right? If we are talking about excavated earth that might have some pieces of other buildings inside and that would give no emissions, I would say it can be used. But of course, if we are talking about chemical pollution and contamination, it has to be treated in order to be used, but because it will be really in contact with the indoor space. So if it is this type of heavy chemical pollution, I wouldn't use it in directly in construction. It would be treated firstly. But I think it really we are really talking about former industrial sites, right? If you're talking just about normal sites, even our the pollution, all of the pollution we have in our water flows, that doesn't affect Earth in a bad way, so that it can't be used anymore. We're really talking about former industrial sites.
Great. Now, Esma is asking, I would like to ask something about one of the slides. I missed the name of the technology of the studio that students could practice on a hybrid system with timber frame and earth. Could you please repeat? You mentioned that it could be disassembled. I do work on the design for disassemble, and I would like to search for the system in more detail.
Okay. I'm gonna write it in the chat. Is that right, Fabio?
Yeah, for sure. That's the best.
So I'm going to write it here. So the prototype was called Terra Nostra. Sorry, I have Terra Nostra. And it was by IAAC, Grenoble School of Architecture in 2016. I'm also leaving you my email, so that if you have any question about Earth, I would be glad to see that with you.
Thank you very much. I definitely will.
You can stalk me.
Thank you, Esma. Sani is asking, I want to ask how important you think it is to look into additive, non-cement, to improve the strength of the soil. Is there a lot of research into this going on globally, or would it be more important to focus on improving the method of construction for the material as it is?
Well, of course, using the material as it is what makes more sense to me. But of course, there is also research going on about natural additives or additives that are not affecting recyclability. It is most for techniques that are wet, techniques that have a lot of water inside, in order to reduce the amount of water that we need to work with the material, and therefore to improve the final performance of the material. But for instance, round earth, we don't get that much by stabilizing it. The main point is water resistance, right? The performance we have toward water. But this maybe it is smarter to be achieved just with some coating or with some coating additives. There is a huge research about the natural additives that are traditionally used all over the world in order to coat earth, in order to make it more resistant toward the weather. I think this kind of researches are what are more interesting in my opinion. But yeah, there are many others. There are about tannins, about biopolymers. There are really a lot of research about additives that we can use in different techniques, of course.
Great. Okay, I will go with another one, maybe one of the last one or the last one, because we don't have much time left. It says, Olivier, he says, my question is the following, and maybe a very Canadian one. Do you know any projects, experiments, or attempts of building with earth in other territories? Depending on the region, here in Quebec, we have thermal differential of around 80 degrees Celsius annually, making insulation, envelope sealing, and water repelling construction techniques very serious problematic.
So the question is whether I know any project in Quebec.
Yeah, in the northern. He says in the northern territories.
in the Northern Territories. Well, actually, earth was a traditional building material in Northern Europe. I don't know that much about Quebec, but for instance, in Scandinavia, it was used, and in Northern, in UK, in Ireland. I mean, even in climate that has some important temperature difference. I don't know about Quebec, but I'm definitely going to look it up. And yeah, I mean, earth can be used as a building material even in severe climates. We will need to have some thermal insulation in our concept, of course, but there is no reason why it shouldn't be used.
Okay, great. Christopher says, can infertilized soil be used as a construction material?
Infertilized, you mean non-organic, just mineral? Yes, this is actually what we look for when we are searching for earth for building. We don't want to use the organic part, the first layer of earth, the most superficial layer of the ground. We don't want to use it on one side because it would bring some life inside of our building, and we don't want that, right? We don't want to have plants growing in our building. But on the other hand, it's also because it is a very valuable material. The humus, the organic earth we have on top of the ground, is the material that is able to really give birth to plants, and that's what we want to keep for agriculture and not use for buildings.
Great, thank you. Well, we don't have much time left. Elisabetta also shared with you your email, so you can send her your questions later, because there are some questions around. I now, before closing the lecture, I know Vicente want to add something.
Yeah, Elisabetta, thank you for your wonderful letter.
Thank you for inviting me.
Yeah, and I'm sure our students are very enthusiastic about your work. You know, we are working a lot with wood as a renewable material, what I think is great. But then some of the questions that students from Iran, from Morocco, or from some other parts of the world where there are no wood, they say, and what about us? No? So the question is if Earth can be as it was. I mean, I was in some of these villages in Morocco with incredible construction with earth. The question is if Earth can be to these countries the equivalent to what wood is to other countries, that they have wood that used to be the material in the past and now has been somehow industrialized in order to reinvent the way we work with it, no? So, well, this is just a question I want to keep open, because I would like to explore with you in the near future how we can deal about this. You know, in Valldaura we used to have a brick factory, so that means that there is a very good earth, because many bricks that are in Valldaura themselves were produced there. And then this is, I know that also some of the 3D printing we're doing at the IAAC was done with using earth from Valldaura. And I think that this is a very interesting topic to continue exploring with you. So maybe we would like to invite you to come in the next weeks, yeah, when the situation is a bit better, and yeah, we can talk about this. Yeah.
I would be really glad to do it. I fell in love with Valldaura when I came to dig earth, exactly, and I would really glad to come back and to explore the possibilities of the earth you have there. I've seen you have different types of, so there is a lot to be said.
Good. So thank you very much, and thank you very much to everyone that join us. Fabio, you can close.
Yeah, sure. There is not much more to say. I think everyone's fascinated with Elisabetta's lecture, and everyone is very interested. So we are going to have, for sure, several conversations in the future. And thank you again for your time and your wonderful presentation.
Thank you, and thank you to all of the 150 people who attended. I'm really glad to be able to share my passion for earth with so many young designers.
Great. Thank you. Good evening, everyone.
Good evening.
Bye.